Section 2.4, dividing fractions. Now, with multiplying fractions, you saw if we use prime factorization, everything is smooth and efficient. Well, the same thing holds true for dividing fractions. I'm going to actually look at practice problem 2 on page 111. This problem is 24 over 35 divided by 8 over 21. Now, the great part about division is technically we don't divide fractions. What we do is we change division to multiplication of the reciprocal. So what we're going to do is we're going to take division and we're going to change it to multiplication of the reciprocal. Now we know what multiplication is, and we know the relationship between division and multiplication. Actually, I could put a double arrow this way because remember we talked about they go back and forth. Now what is the reciprocal? Well, let me give you an example. If you had 2/7, the reciprocal is 7 over 2. You flip it. You take the inverse of it. Something I do want to point out, this has nothing to do with the sign. Notice it does not ask you to do anything with the sign when you take a reciprocal, so please keep that in mind, especially as we move forward into integers toward the end of the course. Reciprocal has nothing to do with signs. So what we're going to do is we're going to do this every time we have division. We're going to do nothing to the front one. Remember, we read left to right. We don't do anything. As soon as we get to division, we change that to multiplication, and then we take the reciprocal of what's behind the division symbol. So we flip 8 over 21 to 21 over 8. Now that's the new piece. The new piece is this division becomes multiplication of the reciprocal. Now if you notice though, isn't this something we just worked with in the last section? It's just multiplication of fractions. Well, that's great because we know all we have to do there is put the 2 together on the top, put the 2 together on the bottom, and then now we just prime factor. So we go back to our prime factor and let's do 24, 21, 35, and 8. Alright, let's start with 24. We start with 2. 2 does go into 24 because that's even, so 2 goes into 2 itself once. We scratch it, nothing left. 2 goes into 4 2 times. Then we continue with 2. Does 2 go into 12? Yes, it does because the 2 is even. 2 goes into 12 6 times. We continue with 2. 2 goes into 6. It does 3. And we've reached a prime number. So we know 24 is 2 times 2 times 2 times 3. Okay? Now let's do 21. 21, 2 go into 21? No, it's odd. Does 3? Yes, 2 plus 1 is 3. So 3 does. It goes in there 7. So we know that that's a prime number and we can stop. 3 times 7. Alright, let's do 35. 2 go into 35? No, because that's odd. Does 3? No, because 3 plus 5 is 8. Does 5? Yes. 5 goes into 35, 7. We can stop. So we have 5 times 7. And then finally 8. 2 goes into 8, yes, because it's even, 4. 2 goes into 4, yes, 2. We can stop, it's prime. So it's 2 times 2 times 2. So now we just cancel. We have 3 2's here. Those will cancel these 3 2's here. We have a 3 up here, but not on the bottom. We have a 7 on top and bottom. And that's it. So it looks like we have a 3 times a 3, which is 9, over a 5. So we have 9/5 is our result. Now something to keep in mind here is as we don't change this into a mixed number. I haven't taught you this yet. We're going to wait and do that in chapter 3. So don't change that. Leave it as an improper fraction here. Okay? So leave this as 9/5.